Good morning, good afternoon, and good evening. Welcome to the ICAO-IATA Joint PBN webinar, Update to the PBN Manual, Edition 5. I'm Tomonori Tsuruzono, PBN Study Group member from IATA and the co-host of this webinar today. So I would like to explain the schedule and the rules today. First, PBN Study Group member presents the key point of the PBN Manual next edition, then move to the Q&A session regarding item in this presentation and the questions in your registration form. We expect the session today to be 1 hour 30 minutes to 1 hour 45 minutes. And in this webinar, we would like to have a few rules for smooth communication. First, your microphone is always muted. Second, please send your question from a question tab. I think you can see the question tab in the webinar menu. Please open the tab and send your question to organizer and the presenters. The moderators of Q&A session will pick up the question from the post and ask panelists. We can have limited time for Q&A, and answer the questions will be posted on ICAO or IATA website after this webinar. So today, we have 6 presenters from ICAO and the PBN study group present this webinar. Presenters, please introduce yourself in the order shown on the slides, and if possible, switch on your camera. Please start from Ian. Thank you.
Thank you, Tomo. Good morning, good afternoon, good evening, everyone. My name is Ian Knowles. I work for ICAO in the Montreal headquarters. I'm the secretary of the PBN study group. I'm a technical officer with Ops and PBN, and I'm currently the acting chief of the operational safety section in the Air Navigation Bureau.
Good morning, good afternoon, and good evening, and thank you for joining us today. My name is Jeff Burtonshaw. I'm the chairman of the PBN study group since 2018, when I took over from Franka Pavlicevic from Eurocontrol. I'm currently the technical development support engineer within the Flight Operations Department in the UK Civil Aviation Authority.
Good morning, good day, good evening, everyone. I'm Barry Miller. I'm an aerospace engineer and technical pilot working for the FAA in aircraft certification. I'm a long-standing member of multiple public forums where we established public standards for PBN, and I'm also a longtime member of the study group. Thank you.
Good day, everyone. I'm Benoît Roturier. I work for the French Civil Aviation ANSP, which is called DSNA. I am program manager for CNS, satellite CNS implementation and PBN. Concerning PBN study group, I was the rapporteur. I am the rapporteur of the ATM working group, and I am the nominated member for France.
Good day, everyone. I'm Dave Zaitouni. I'm a technical fellow at Boeing and a member of the PBN study group. I work in the flight deck engineering group for Boeing commercial airplanes as the flight deck architect. Thank you.
Hello, everybody. I'm Tomonori Tsuruzono, senior manager ATM infrastructure IATA in Montreal. And unfortunately, Dave Nakamura cannot participate today. So we have 5 presenters to organize the presentation today. So now I would like to invite Ian to open the webinar. Ian, over to you.
Thank you, Tomo. If we could move on to the next slide.
Yep. Okay.
So thanks everyone for the introductions, and welcome to everyone. Thank you for your interest in the new edition of the PBN manual. Just to confirm, the main focus of this webinar is to present those the major changes to the manual from the last edition. That was edition 4, published in 2013. There will be an opportunity, as we've already mentioned, to respond to some of your questions at the end. So the first part of this presentation really is going through the manual and highlighting the major changes to the 5th edition, and then we'll have an opportunity to address those questions. So do please use the question opportunity of the question function on the webinar to pose any questions that you would like answered that come to you as we're going through some of these points during the presentation this morning. As Tomo mentioned, if we run out of time to answer all the questions, we will endeavour to get a response drafted to that and make those available probably via the ICAO and IATA public websites, just so you can have an opportunity to get the responses to those subsequently to the webinar. Okay, moving on to the next slide, please. And again. So before we start, then just a quick reminder of the overall structure of the PBN manual. I'm sure you're aware that the manual itself is divided into 2 volumes. The intention, although there are 2 separate volumes of the manual, was that always that they would be kept together. So it's published as a single entity, but the material itself is divided into Vol 1 and Vol 2. Volume 1 then covers the basic concept of performance-based navigation, some implementation guidance. It talks about the description of various items, the airspace concepts, the uses, etc. Volume 2 then goes into implementation of RNAV and RMP operations. It starts with the description of the onboard performance monitoring and alerting, and then into Part B we get to the implementation of the RNAV specifications and Part C of the RMP specifications. Now that basic structure of the PBN manual is retained in edition 5, so we haven't done anything major with the way the information is presented. The majority of the changes are either additional information that's come up from several years of successful implementation, or there's some new elements that have been brought in. But basically speaking, the structure of the manual is the same as edition 4. Next slide, please. So when reviewing the manual, it was decided actually that there was quite a lot of information that was duplicated within Doc 9630, within the PBN manual. A good example of that is the information that was relevant to the airspace design. This is actually already covered in another documentation. It's covered in Doc 9992, the manual on the use of performance-based navigation and airspace design. So that information has now been removed from the PBN manual, so that we can focus on getting it all in one place. Rather than having the similar information in 2 different manuals, it's all going to be concentrated into that one manual from now on. There's been a number of clarifications and additions. So for example, there's information on the use of RF legs on PBN in the free route concept, on the use of either an RNAV or an RMP nav spec, and some additional guidance on the use of GNSS reversion. A lot of this material, I'm kind of presenting a high-level overview at the moment. All this will come back to in some of the subsequent speakers will pick up on a little bit more detail. Next slide, please. So one of the key changes that we made, and it's not immediately obvious, but the definition we have currently for area navigation, the existing definition that's in the PBN manual, talks about a method of navigation that permits operation on a desired flight path within the coverage of ground and space-based navigation aids. And then there's always been this note underneath that definition that talks about the area navigation, including performance-based navigation, as well as other RNAV operations. If you can hit the next advanced button, because it should put a line through that. So the intent of the change here is to remove that note, and then have the area navigation basically defining the method of operation within the operation on the desired flight path within the coverage area. But we no longer have reference to area navigation being PBN plus other. So really moving to this point now, PBN has been around for long enough and established long enough that in fact we do not really consider that there's anything else that, excuse me, I'm having a, apologize for the interruption there. So it's been around long enough that actually we don't think area navigation does include other things apart from PBN. Now really what we're saying is that if it's area navigation now, it should really be within the concept of the PBN operations. Additional changes that have been brought in, and again, this will be covered in a little bit more detail by a subsequent speaker, but the reference to holding within the PBN concept, it's always been a little bit difficult because there aren't that many nav specs that actually have a concept of holding in them. However, we're aware that the RNP RNAV systems are used for holding, so we'll cover that in a subsequent presenter's talk. We'll go into that in a little bit more detail. Also, with the use of GBAS coming in as a potential positioning, so it's not that we're introducing GBAS approaches into the PBN manual. That's not something that has been done, and nor is it likely to be done, but certainly taking advantage of the GBAS information as another way of providing position information for PBN. There is a change in the terminology that's used regarding the way we talk about approvals for PBN. This is work that originated with the Flight Operations Panel of ICAO, and it looks at, historically we've had this concept of the ops approval, and really it's been sort of in generic use, and we've taken it to mean that an ops approval is something that requires a specific approval and it goes on the ops spec, and there's been some inconsistency around how that terminology has been used and applied, particularly within Annex 6 and supporting documentation. So in fact, you'll see in the 5th edition that terminology has changed, and really when we're talking about the approval basis for PBN, we refer now instead to the authorization. And the authorization really covers both the specific approval, a more generic approval, and also acceptance actions. It's anything that requires the state of the operator to authorize, to allow for the operation to continue. And within that, we have different levels of authorization, the specific approval for RMPAR, for example, and the more generic, either an approval or acceptance, depending on what the state has established for the rest of PBN. So you'll see the terminology has changed a little bit, and that's a little bit described at the beginning of the manual. Next slide, please. I think actually the next slide is just going to put a line through the through the note underneath the area navigation. Moving on, thank you. So more changes to volume 2, and again, I won't go into this too much detail. The Barra VNAV attachment that was at the end of Vol 2 has been removed. It's been replaced instead by an attachment which talks more generally about vertical navigation, and our colleague Barry Miller is going to talk in more detail about that later. There's some discussion about the use of RMP approach and RMP-AR approach operations in non-standard temperature, and also more detailed discussion about magnetic variation, MAGVAR. You also see at the end of the PBN manual a single attachment which collects together all the various document references for information relevant to PBN approvals. They're all gathered up together into that attachment at the end of Vol 2 as well. And also there's been some changes to the onboard performance monitoring and alerting, and again you'll see that covered in a subsequent discussion. So at this point, just to raise the fact that it's coming up, and we'll get to it shortly. Next slide, please. There's also been some additional information provided for improvements and advancements in GNSS. So there's more discussion about the use of dual frequency multi-constellation, DFMC, and also there's a little bit more of an explanation about monitoring requirements, and I believe Benoit will be talking about that shortly. Another change in terminology that you'll notice reading through the manual, you'll see that there's been some clarifications about the terminology, or how we refer to the navigation specifications as opposed to the lateral navigation accuracy. So we have a PBN nav spec, which is RNP 0.3, which is a helicopter nav spec. And we also have, for example, in the final approach segment of RNP approach, we have a lateral navigation accuracy, which is 0.3 nautical miles, historically referred to as RNP 0.3. Similarly, we have RNP1 as a nav spec, and we have 1 nautical mile lateral navigation accuracy, which is previously been referred to as RMP1. So in order to be a little bit clearer within the manual now, whether we're referring to RMP 0.3, the navigation specification, or RMP 0.3, the lateral navigation accuracy, you'll see that those have been slightly amended. The lateral navigation accuracy now will be referred to as 0.30 and 1.0 respectively, and the nav specs will be RMP 0.3 and RMP1. So it should hopefully clarify any issues with understanding when you're reading through the manual, whether we're referring to RMP 0.3 as the helicopter nav spec or RMP 0.3 as the navigational accuracy, 0.3 nautical miles. Similarly, there's been a change in the terminology we use to talk about the inertial navigation system. So We've had various terms in different parts of the manual, INS, IRS, IRU, those have all been removed now, and you'll see just one reference to inertial navigation system in all of those cases. Moving on, please. So again, my colleague Barry Miller is going to look a little bit more detail about the RMP AR requirements. So I'll just kind of highlight here that there have been some changes to Chapter 6 for the RMPR, what used to be RMPR approach and now incorporates DP. I'll let Barry go into a lot more detail about that. And along with that, there's some update to the FOSA material, which has been updated in line with more current practice. There's also been changes to the advanced RMP NavSpec ARMP, which will cover, I think Jeff Burtonshaw is going to cover that. And one significant change, just to make the point, the RMP 0.3 NavSpec used to say that this was primarily for helicopter applications, but does not exclude the application to fixed wing operations. Now it does. So now it says quite clearly and explicitly, RMP 0.3, the navigation specification, is a helicopter NavSpec. So that's an important point to take away. So that's basically a very high level introduction of the summary changes, and a lot of those will come into a bit more detail when our other presenters start talking shortly. If we can just skip to the next slide first though. So publication timetable, I know this is something that people are very keen to ask about, and we are doing our best, or rather I am, to get this manual out the door. The PBNSG actually completed the technical content at the end of 2021, so that's all been finalized. It is currently with me in the ICAO headquarters to do a review of terminology and consistency. Some of that we've already discussed. So for example, the authorization, acceptance and approval work, looking at that phraseology that's used to describe how we authorize the operations. There's been a couple of changes elsewhere in ICAO that we need to incorporate, things, for example, related to FFICE. There was a change to how we refer to flight plans that introduces items such as current flight plan and filed flight plan that we need to make sure we are consistent with within the manual, because we have to be consistent within our own documentation. So there's a little bit of work going on right now to make sure that the PBN manual edition 5 is consistent with other changes that have also been made in other parts of the organization. And I'm hoping that that's going to get finished in the very near future. In fact, I'm actually hoping I can get finished with that this week, which would be good. It then needs to go through our editorial process, and we're hoping for publication end of this year or possibly early 23. Earlier if we can do it, but that's subject to resource constraints here, unfortunately. Next slide, please. And just a quick note about related guidance material that's also going on in line with the update to the PBN manual. So we do have a PBN operational approval manual, that's DOC 9997. That is currently also being updated. That work is being done under the management of the Flight Operations Panel PBN operational subgroup. So that's being updated. In fact, it's been a couple of years since that was done. It's a little bit out of sync at the moment, so there's a reasonable amount of work to do there, but we are confident that that work is going to be finalized by the end of this year, with publication hopefully in the early or mid 2023. I mentioned earlier about how the airspace design material was removed from the PBN manual 5th edition, and that the intent is to keep all that within the manual on the use of PBN airspace design, DOC 9992. So there is a plan to update that to the 2nd edition, and along with that, the supporting documents on continuous climb operations and continuous descent operations. We've had some interest from the environmental side of the house, who are very keen to pursue the CCO and CDO in particular as a way to potentially get additional fuel savings. So we're discussing with them right now on how we can move ahead with an update to those manuals and the umbrella manual, which is the 9992. So hopeful that that might proceed. And then in terms of the temperature correction and compensation for the barometric defined instrument approach procedures, I mentioned that there is an attachment at the end of the manual which talks about that. The actual question about the application of temperature correction, whose responsibility that is and how that breaks down, that's all actually in discussion right now within a separate subgroup, which is jointly formed from the flight operations and ATM operations panels, and they're looking at how that whole assignment of the responsibility for temperature correction breaks down, and possibly following on from that, some amendments to both PANS Ops Volume 3 and PANS ATM to deal with that. So there's the related activities that are going on relevant to some stuff that we've changed in the manual, just to keep you all updated. That's all from the general high-level overview, and I'd like now to hand over to Benoit, who's going to take you through the next set of the presentation slides. Thank you.
Thank you very much, Ian. Yes, so I will introduce a few changes that we conducted in both volumes for ATM and Airspace Concept point of view. I would like to acknowledge here the contribution of my colleague, Mrs. Corinne Bousquet, which did a tremendous job around progressing these issues within the manual. Next slide, please. So we have first tried to improve the global and comprehensive view on nav specs throughout the volume 2 introduction, and this is more or less concretized within a number of tables. One which is improved, which is this one, which is quite famous for those of you who knew the PBN manual. It's a matrix form crossing the navigation specification and the navigation application by flight phases, and where you have a number here, it relates to the navigation accuracy, which would be requested for these different flight phases. And when you have nothing, it means that you cannot use in principle the nav spec for this specific phase of flight. So there were a number of clarification in this table. I don't have time here, I think, to go into details. We will skip to the other table, second table, which is a new table, which provide an example of airspace requirements versus the required or optional RNP system functions. So here again, I won't go into details of the table, it's just to give you an overview what's contained within the new section of the manual. Then there is another table, which is new table, which relates the navigation specification versus the RNP system functions, and it clarifies whether the system function is not applicable or required or optional for the nav spec. So we expect also here this table to be an improvement for the reading and the comprehension of the manual. And here you have the cross references between
Benoit, your voice is lost.
only RNAV 5 is supporting optional, all sensors as options. For what concerns DME, they can be used for some RNP application, but you can see there is a footnote here, and if you read the footnote, it's a very specific application. You would need a specific state authorization to conduct this RNP operations through DME or DME inertial navigation. We can go back maybe. So this is it for the global new tables. Maybe let's go to next slide. Okay, so use of RF, since more and more aircraft now are RF capable, we saw that it was important to clarify the use, and in particular the judicious use of RF. In particular for procedure designers which use RF now more frequently outside of RNPR applications. So you have two sets of clarifications within volume 1 and volume 2. So you have a list of considerations for the application of RF within Airspace Concept, and there is a specific point in volume 2, appendix 1, part C, which is explained here, which relate to quite specific application, but which are important in practice. Next slide, please. So in terms of capabilities and functions. So we had a lot of discussion around holding in particular and parallel offset. So it was clarified that holding is not considered as a PBN function, and I will detail this in the next slide. In particular because there are currently no standardized functional requirements to support this as a function. So this is why you won't see it in the table relating the nav specs and the function that we saw previously. Parallel offset is there. It's considered as a PBN function, which is in particular required for RNP4 and advanced RNP. Then we have this clarification, which is important. We thought which was important, which is in red here in the slide, which is that an airspace concept may include either of these two capabilities based on the assumption that the aircraft contains parallel offset and/or holding functions, or for those aircraft without this parallel offset and/or holding functions, flight crews have the means, procedure, and training to perform these aspects of flight operation, and this is noted in Part A, Chapter 1 of Vol 2. Next slide, please. So holding functions triggered quite a lot of discussions to understand the situation and to fix it properly. We hope in this edition of the manual. First, it was recognized that only advanced RNP supports RNP holding as a function, but this only, of course, for future applications because advanced RNP is quite new. For all other nav specs, in fact, airspace designers can implement protection area around waypoints supported by PBN nav spec, and it's currently described as a PANZOPS, the same as the original holding criteria, which was based on the manual method, for those of you who are aware of it. So as there is no standardized FMS method to fly holding pattern, the protection area associated with holding based on a waypoint is directly based also on the same manual method, which means that in practice, there is no operational improvements in terms of airspace impacted, even if you have a FMS holding function on board, is still based on the legacy manual method because we have no standards basically for that. So this is recognized through the manual, and this is also inserted within every navigation specification except advanced RNP as written in red below. And only, in fact, now we consider that only advanced RNP holding function can derive better airspace benefits when implemented. Thank you. Next slide. So in terms of airspace concept, as pointed out by Ian before, here again we have a number of clarifications. First, the use of PBN as an enabler to free routes. So we have updated in this respect the attachment C of volume 2, which describes how you can implement this within your airspace. Another clarification is the use of more flexible operating environment for NavSpec with respect to the density of airspace and the capability of ATS to provide surveillance or not within the airspace. In particular, we clarify that if there is a change from the originally intended operating environment, this requires a specific safety assessment to ensure the adequacy of safety requirements. We also provided some more information, which is an important topic for PBN implementation, which is relevant to the reversion mode in case of Gnss failure. Of course, PBN and airspace are intimately connected to the kind of reversion techniques or strategies that you are able to implement within your airspace. And this is important. I can confirm in Europe at the moment, we have a regulation, you are probably aware, at least for European colleagues, we have PBN regulation, which send us toward 2030 timeframe where we would have exclusive use of PBN. In that context, it is extremely important to understand what happens when we lose the PBN navigation sensors. Next slide, please. Then we have a clarification also on the capability of PBN to support different GNSS systems, and in particular the Annex 10 standardized augmentations. You probably know that in terms of GNSS, we have three standards within Annex 10, ABAS, GBAS, and SBAS. And there is even something new. We have new constellations. We had GPS and GLONASS up to now in the Annex 10. Now we have Beidou and Galileo, which are under approval, and the SARPs should be applicable in November 2023. So you see this is coming. We have new signals in the air. We have new SARPs. We have avionics manufacturer which start to work now around this DFMC avionics. So we thought it was important to clarify how this new DFMC avionics could be used versus edition 5 provisions. So we clarify the application of DFMC, the use of DFMC SBAS and ABAS to support existing navigation specification. As pointed out by Ian previously, GBAS positioning service has been added as a consistent sensor to support navigation specification in terminal airspace. And important to note as well, GBAS for the final approach, which is the main application of GBAS, is still treated similar to ILS, and so it remains within the domain of our manual. It has not been included as a PBN sensor here. So I guess this is all for me, what I had to say. We'll pass the floor to Mr. Jeff Burtonshaw. Jeff?
Thank you very much, Benoit. Thank you, Tomo. So in this next section, what we'd like to talk about is the changes that have been made to Volume 2, and that will be myself talking about advanced RMP. Barry will then talk a little bit about the RMP AR operations, and it'll be David Zaytouni this afternoon who'll be picking up MAGVAR. So getting back to advanced RMP, this is not a new specification. It's been in the manual since edition 4 in 2013, when it was introduced primarily to try and consolidate some of the navigation requirements and simplify the aircraft certification process. We spoke of the time of trying to bundle some of the existing airworthiness approvals for the various navigation specifications into one specification that would do it all. I think on reflection and in the benefit of hindsight, it didn't really make a significant difference from an ATM perspective, and I think because of that, there wasn't any impetus really behind the introduction of advanced RMP as a nav spec in its own right. It certainly made the job, I think, for the major OEMs easier, because they could now declare advanced RMP rather than having to declare all of the separate nav specs. But I don't think it really took off in the way that we had perhaps envisaged it might in terms of the application. Advanced RMP at the time in 2013 reflected what was then the modern aircraft performance. So we were talking really about the Boeing 737 next gen and the A320. So this is a period that is pre-NEO and pre-MAX. But what we wanted to do with advanced RMP is to utilize even the capabilities of 2013 that were available in the main production cycle and avoid the need to invoke specific approvals. So advanced RMP wasn't going to go as was never going to go as far as RMP AR, but it was trying to bridge that gap from maybe some of the other nav specs up towards advanced RMP. But as I said before, it didn't really have any appeal from an ATM environment, and I think that was partly because people didn't really understand how it was going to be used, and it wasn't adopted. And in some cases it was adopted, but perhaps in error, because when I looked at some of the charts of the time where advanced RMP had been specified, it was difficult to see why the other nav specs didn't in fact cover what the application was trying to do. So we had to try and refocus what advanced RMP was trying to do. And the final point there, it was the charting. So at the time, certainly we weren't helped by the chart in terms of identifying specific PBN requirements. We now have, thanks to Circular 353, the introduction of the PBN requirements box, and I think we have a better way of communicating just what the specific NavSpec requirements are within any application. Next slide, please. So within edition 5, what we're trying to do, I think, is we felt the need to provide further explanation on how to implement advanced RMP. And in edition 5, we now have an appendix included within volume 2, part C, chapter 4, which is advanced RMP, which really gives you more scope and applicability, but also addresses the stakeholder considerations. And those are stakeholders such as the states, the operators, and the original equipment manufacturers. We've also put some guidance in there for the regulator and the equipment standards in terms of, again, where advanced RMP sits with that material. One of the changes that we've introduced here is we've removed the final approach segment from the scope of the NavSpec. So we've made advanced RMP really sit outside of the final approach segment, and then you conduct that final approach segment either through the RMP approach, NavSpec, RMP AR approach, or with an XLS, that's an ILS, MLS, or GLS. The other big change, I think, from edition 4 to 5 is that we've made advanced RMP a fixed 0.3 nautical miles, or I should say a 0.30 nautical miles lateral navigation accuracy in terminal airspace. So this covers us 0.30 for the arrival procedures, initial and intermediate approach, and departure procedures. And that is a significant change insofar as it's now a fixed value. Previously in edition 4, we had this concept of scalability anywhere between 0.30 and 1.0. And indeed, PANSOPS Doc 8168 has scalability in there today. But I think to enhance the appeal of advanced RMP, what we felt we should do here is, and given that the aircraft were all capable of doing this, we felt, why are we not just specifying this as a 0.3 spec? Because then you can design your terminal airspace with that in mind, rather than trying to apply a form of scalability less than 1. So that's probably the most significant change, I think, in advanced RMP in edition 5. It was true, I think, scalability, not everybody understood what we were talking about by that term, so best avoid it, and it's been removed. We are talking in this specification, as in all of the specifications, about the normal navigation performance in this flight phase. So we're not talking about any contingency or reversionary capabilities. We are talking about normal performance. And we feel that by doing these changes, what we're doing is making the NavSpec more attractive to the airspace designer, where advanced RMP could stand alone as a distinct specification, rather than just having this bundling of RMP1 and RF and other features. But what I would say is that it doesn't go as far as RMP-AR. That is still a very distinct navigation specification, which will require a specific approval. But I'll talk a little bit more about the approvals for advanced RMP in a minute. Next slide, please. So in this slide, what I've tried to depict here is the differences between edition 4 and edition 5. And you can see that certainly in the arrival approach and the departure phases, we now have this 0.30 fixed lateral navigation accuracy. And we've removed any accuracy requirement within the final approach segment. As I said before, that is either an RMP approach, an AR approach, or indeed an XLS approach. We still have the scope within advanced RMP to cover the en route oceanic remote for RMP2, and indeed the en route continental for either RMP2 or RMP1. The notes at the bottom there is just really to try and help explain where we see the nav specs being used. And the last note there in particular is important, I think, because one of the discussions we had for the missed approach segment was very much, would we consider 0.3 in the missed approach? And here we did have an overlap with perhaps some of the AR requirements, and where AR requirements probably are a higher standard and still required. But we did put the scope in there that there could be an individual safety case for the missed approach, given a certain number of considerations to reduce the lateral accuracy down to 0.3. But the normal case would be a missed approach of 1 nautical mile lateral navigation accuracy, exceptionally 0.3 subject to safety case. Next slide, please. And here is the considerations that we've identified for missed approach, which would justify going below the 1.0. So it's as it says there, it's on an exceptional basis, subject to safety assessment. I think the main important point is the aircraft eligibility, and in particular, if you're doing 0.3 in an AR context, then you require an inertial navigation system, and we felt that that was one of the main factors here that would justify 0.3 in an advanced RMP context, notwithstanding the protection services. It was the ability to extract the aircraft from a 0.3 missed approach that we felt was important, and where the inertial navigation system was required. I think it's important also that the provider of ATM and ANS also has well-specified contingency procedures. So if you're going to go to 0.3, you need to consider just what the extraction procedures are going to be from whatever environment you're considering, be that in terrain or an ATM environment, busy traffic. And indeed, within that, you should do, as with any NavSpec really, consider the ATM infrastructure and how well you support both the common surveillance as well as the navigation. The design for the missed approach path, and in particular the first turn point, and especially if RF is used, that is a consideration here for how you design the advanced RMP in this context. And again, it's one of those elements that has similarities with AR, but it's not AR. And then finally, the publication and charting, and including how the navigation database would allow particular aircraft to fulfill the credit of 0.3, and how those aircraft that weren't eligible could be excluded. So the database consideration is again another major point. I think that from the lengthy discussions that we had within the study group, and in particular from our regulatory contributions, there was a concern that advanced RMP did not become a workaround to avoid the more appropriate adoption of RMP-AR. There's a reason that we go to RMP-AR, and Barry will talk about that in a minute. But advanced RMP does offer, certainly in busy TMA areas, an ability to have efficiencies over what we have today with just the RMP-1. We have provided a pathway though for the 0.3 in the missed approach, but as I said before, it is subject to safety assessment and some possible controls being applied to that particular application. Next slide, please. So just focusing on some of the flight operational aspects of advanced RMP. Advanced RMP operational authorization, and note that I'm using the term authorization in this context, it's not a specific approval, is envisaged to be very, very similar to that which is established for RMP-1 today. So that will mean that the operator is good for both RMP-2, RMP-1, and then in those flight phases, initial, intermediate, and missed approach segments, and the RNAV5, RNAV2, and RNAV1 specs. So in that respect, it is still a bundling spec, but it must also be good for the 0.30 lateral navigation accuracy and those exclusive advanced RMP capabilities such as RMP holding. Having got that airworthiness aspect of it, then it should be, advanced RMP spec should be specified in the requirements box or equivalent notes on a chart. So it will identify the distinct need for advanced RMP as opposed to RMP-1 or RNAV1. And again, it should be there applied on the SID, the STAR, the transition, or on the approach. So those are the applications of it. But what I would say is that from an operational perspective, what we're talking about is probably an authorization, as I said, similar to that which today is granted for, say, an RMP1 authorization. So it might be an ops manual amendment or some other similar amendment or ops spec amendment, but it's not a specific approval. And the reference material that we've listed here is AC 90-105 alpha for the FAA, and that will be superseded by AC 90-119 in due course. And then from a European perspective, Commission Regulation 965, which is AirOps, and we have CATOP MPA for aircraft of 126 and 345 for the instrumentation. So the requirements are out there, and there's no reason why operationally advanced RMP shouldn't be authorized today. It just needs to be applied, and that's where we need the airspace and the ATM to move to adopt those enhancements. That's all I have on advanced RMP, so I'd now like to hand over to Barry and ask Barry to speak to the changes that have been made in Volume 2, Part C, Chapter 6 on RMP authorization required. Thank you, Barry.
Yeah, thanks, Jeff. One of the issues we faced with the existing manual was the volume of feedback that the states were providing both operators and the regulators themselves with regard to the issues of difficulties they were having with implementing RMP operations. And along the way, as an airworthiness regulator, we also saw issues with confusion from some of the manufacturers as well. And that led to an effort by the study group to do a wholesale update of the RMP-AR nav specs in Volume 2, which led to an effort to expand that navigation specification to add RMP-AR departure procedure navigation specifications, as well as a need for better guidance, more explicit guidance on how a flight operational safety assessment, or FOSA, can also help distinguish RMP-AR approach operations from some of the proprietary and what here in the United States, at least, we call special RMP procedures that have been tailored for specific aircraft and specific operators around the world. So what we wound up doing with good consensus from the study group was we embarked on an effort to create a new Chapter 6 titled Implementing RMP with Authorization Required. And that Chapter 6 includes both RMP-AR approach and RMP-AR departure procedure navigation specifications. Next slide, please. One of the major issues we had was just simple terminology. So as we put Chapter 6 back together to embrace both RMP-AR APCH and RMP-AR DP, we tried to take care in our description of the navigation specification to distinguish between RMP-AR operations and actual RMP APCH procedures as well. So there was a major effort to try to clean up and put much of the navigation specifications in better harmony with very clear, direct statements assigning responsibility and trying to embrace the distinctions between the operations and the procedures themselves. Next slide, please. So what we did was, in this effort to embrace RMP-AR DP nav specs, was we wanted to make sure that we were taking care to merge the aircraft's takeoff and climb performance with the aircraft's navigation performance. So around the world, some of you may know that we've had quite a bit of experience with special RMP-AR departure procedures, proprietary RMP departure procedures, as well as a variety of states have implemented quite a number of RMP-AR approach operations in support of public operations. But what we did do was we took careful consideration and based on feedback we received from many with regard to the special RMPAR departure procedures, that we came to consensus that we were going to limit RMPAR DPs to the application of an accuracy value of RMP 0.30. On top of that, what we tried to do was make sure that the new navigation specifications for RMPAR DP embraced the aircraft type certificate requirements that regulators embrace for takeoff and climb performance, including one engine and operative performance. And what this entails is it creates a requirement for the operator to have detailed takeoff and climb performance data, including data for non-standard climb grading. And in part, this will require some operators to go back to the aircraft manufacturer because they may need additional aircraft performance data to support the actual demanding RMPAR DP operation itself. We also had quite a bit of discussion about requiring for planning for loss of an engine. In other words, ensuring that the RMPAR DP operation embraces concerns about one engine and operative performance. And we did that because statistically, loss of an engine is probable across all phases of flight, and operationally, it's a best practice on every takeoff and departure to plan for loss of an engine. Next slide, please. So the concern became, how do we express the requirement to extract the aircraft from a demanding RMPAR DP when there's one engine and operative? So what we decided to do was embrace the manner in which many operators around the world conduct day-to-day operations from many challenging airports. So we want to ensure through the nav spec that the operator shall be able to embrace the aircraft's ability to either fly the RMPAR DP's defined procedural path after experiencing loss of an engine, or offer other options as mitigations for the operation when one engine fails. Essentially what we did was we based it on the success we've had here in the United States with FAA AC 12091, which is titled Airport Obstacle Analysis. The other major concern that we had with RMPAR DPs was what type of aircraft eligibility requirements are necessary to support close-in turns. So we got a lot of feedback from the avionics and aircraft manufacturers that formed the foundation for the new definition within the DP nav specs to perform such close-in turns. One of the major concerns we have from an airworthiness perspective is that the aircraft's takeoff phase of flight shall be complete before turning during an RMPAR DP. That's because the aircraft's type certificate does not support turning the aircraft in the takeoff phase of flight. Instead, what we're trying to make sure occurs is the aircraft performance supports completing the takeoff phase of flight such that an RMPAR departure procedure can place an RF leg at the runway's end, at the departure end of the runway. As we did that, part of the concern was, how do we ensure that the aircraft's RMP system is also supported by the definition of the procedural path? And as a result, we discovered, thanks to feedback we got from avionics and aircraft OEMs, that the path may need to be defined from the approach end of the takeoff runway through the departure end of the runway in order to enable that aircraft's ability to actually sequence successfully into an RF leg that is beginning right at the departure end of the runway. Next slide, please. We also took careful care to try to work with the new criteria working group of the IFPP, and some of the feedback we got from those proprietary special RMP DPs that exist today. And as a result of discussions and debate, we wound up that whenever the RMPAR departure procedure requires the use of an RMP value less than 1.0, the RF turn bank angle shall be limited to a maximum bank of 20 degrees. One of the major concerns we had was trying to ensure that the RMPAR DP nav spec embraces the maximum number of aircraft eligible for RMPAR APCH, RMPAR approach, and as a result, by limiting the bank angle to 20 degrees, we believe we're capturing all of the aircraft that are eligible for RMPAR approach today. What this does is it provides, based on the existing performance of the aircraft eligible for RMPAR approach, a 5-degree buffer in the available bank angle that allows the RMP system to correct to the path when it encounters any disturbances taking it potentially off the path. We also had a lot of practical experience with aircraft speed potentially corrupting capture of guidance for a first turn after takeoff is complete. So in order to enable the ability to conduct close-in turns, that we define as a turn within 1 nautical mile of departure into the runway, procedurally, there will be a speed constraint of 210 knots indicated airspeed anytime that turn is within 1 nautical mile of the end of that runway. This ensures that the aircraft's RMP system has the ability to do accurate turn anticipation such that it can properly lead the capture of, for example, an RF leg segment that's within 1 nautical mile of the departure into the runway. And again, this was based on actual experience, not just our hypothetical assumptions of how the aircraft are going to conduct a close-in turn in a demanding RMPAR DP. Next slide, please. The other thing that I want to emphasize is that while we do embrace one engine and operative performance, the RMPAR DP procedure design shall consider the normal performance of the airplane. In other words, it's not the job of the procedure designer to decide what type of contingency plans the operator shall develop in order to embrace concerns about loss of an engine. So as a result of that, we try to clarify that in the navigation specifications and provide those options to the operator for considering and planning for loss of an engine. Of course, I already mentioned you can fly the published RMPAR departure procedure with one engine and operative. You plan your aircraft's takeoff and climb performance to ensure you can stay on the path. In today's proprietary special RMP departure procedures, this is very, very common that the operators conducting those procedures limit the load of the aircraft to ensure that they can fly it should there be a loss of an engine anytime after the takeoff is committed. However, there is flexibility in other options that can support a safety case to conduct RMPAR departure procedures. For example, you can have an alternate tailored departure procedure for an individual aircraft type for a specific RMPAR departure procedure that can be published in the aircraft's onboard navigation database. Many of the aircraft today allow the flight crew to have an alternate procedure available for quick implementation through the manner in which the onboard navigation database and the RMP system CDU work together today. So this type of procedure could be immediately available should the flight crew lose an engine, and then once they've taken care of their memory items and other concerns with loss of the engine, they can transition to fly this alternate tailored departure procedure that provides safe separation from obstacles and terrain. Likewise, we've got a lot of experience here in the United States with some of our challenging airports where another option can be to develop a contingency plan to fly a specific published and approved pilot procedure. In other words, the regulator overseeing the RMPAR operations would have to take a look at that pilot procedure, agree with it, and then it can be published in the operator's flight information guide, or what many operators have today for many of the operations from specific airports, their guidance for their flight crews, such that a pilot procedure, for example, a turn to a heading and a climb to a specific altitude to get the aircraft to a minimum safe altitude. That too is a credible operation during an RMPAR DP when an engine failure occurs. Next slide, please. Along with the major updates that we did to Chapter 6 to embrace the introduction of RMPAR departure procedures, many of the states and operators were concerned about what type of flight operational safety assessment need be done in order to support implementation of safe RMPAR ops. So as part of that, we made a new section in Chapter 6 of Volume 2 that embraces RMPAR operations and FOSA. The issue we had was ICAO doesn't have guidance for non-public RMP procedures or special proprietary RMP procedures that are in service around the world in many, many states. So we offered guidance to the states on how they may apply FOSA to these non-public proprietary special RMP procedures that are in many cases non-compliant with the RMPAR procedure design criteria in document 9905 and may or may not be consistent with the state's RMP design criteria that they may have for their particular implementation. What states may also do is choose to exclude non-compliant procedures from their public AIP. So part of what's described in this section, it makes the case that in order to ensure that you're doing a proper FOSA from a state perspective, you have the opportunity to withhold these proprietary non-public RMP procedures from others by not publishing them in the state's AIP. There's also a good flowchart in the FOSA section that tries to help states distinguish between public RMPAR procedures versus those that are non-public and how they fit into this consideration for ensuring that you've got the safety case to offer both types of procedures during day-to-day operations. The guidance also doesn't just stop with some clarity for the states. It tries to offer guidance to the individual operators that are going to conduct RMPAR operations. Again, it provides a bit of a flow chart to provide some high-level guidance for the operator's evaluation of RMPAR operations. And it's really focused on trying to clarify that from the operator's unique perspective relative to what hazards may occur from an operational perspective during conduct of RMPAR approach. Next slide, please. So the entire goal of what we did in trying to do this wholesale update of Chapter 6 of Volume 2 to embrace RMPA operations is to get aircraft safely into challenging airports like the one depicted on this slide. And not just get the aircraft into that airport, but as you can see, once you get in, you need to get out. And so we offer the new navigation specifications for RMPAR departure procedures such that in these unique situations around the world, you've got an opportunity to safely get into that airport and get out. Thank you. Next slide. Another update we made to the manual to hopefully offer some clarity to the users of the manual was a lot of confusion about VNAV, vertical navigation in the final approach segment. We had an attachment A that offered for years clarity on both the airworthiness and the operations approval basis for use of barometric VNAV vertical guidance during RMP approach operation. But that specifically just focused on baro VNAV. So when we got the feedback about the confusion that existed with the use of VNAV in general, we decided to update attachment A to support a more generic approach toward VNAV application in the final approach segment as it's supported by the RMP systems during PBN operations. So what we did was we focused this new attachment on VNAV supported by it and the aircraft's airworthiness approval itself, such that when an RMP procedure requires VNAV, for example, if you're going to execute the LNAV VNAV line of minima on an RMP approach, then you want to make sure that you have approved VNAV or VNAV for operational credit. And where procedures don't require VNAV for operational credit, then we introduce the term that's commonly used by many regulators in states of advisory VNAV. We also clarify that VNAV may source from both barometric VNAV, which is a specific airworthiness approval, or Gnss VNAV, which is another specific but distinct airworthiness approval. In both cases, these types of airworthiness approvals for VNAV are generally provided to aid the pilot's vertical situation awareness and help in the conduct of smooth descent operations, as well as the conduct of a continuous descent final approach operation as well. So that led to issues with confusion of, well, where do we require VNAV and where do we conduct procedures that don't require VNAV? So this new attachment offers some clarity by specifically describing and defining that procedures requiring VNAV include ILS, MLS, GLS, and RMP approach flown to the LNAV VNAV or the LPV line of minima, and then every RMPAR approach requires VNAV to fly any of the lines of minima that are defined by RMP values. We also try to clarify that there are procedures that do not require VNAV. For example, an RMP approach flown to LP minima, or the RMP approach that just has LNAV minima, or the operation itself is constrained to LNAV only minima on that given day. There is no requirement for VNAV of an approved source to conduct either of those operations. We also provide some enhanced guidance on the distinction between conducting an operation to a decision altitude versus doing so to a procedural MDA, and we offer some broad aircraft eligibility guidance with respect to those two distinct operations and how they're conducted through the use of either approved VNAV or in the operation down to an MDA, more typically with advisory VNAV. Next slide, please. Another issue we had all along with the manual was confusion about onboard performance monitoring and alerting, or what euphemistically is called OPMA and its concept. Fundamentally, what we did was we took a look at Volume 1 and Volume 2 references to onboard performance monitoring and alerting, and we made sure that we weren't corrupting the original concept that is in today's manual. But what we did do was we tried to offer some clarity by refining the description of OPMA to ensure that we're making it clear that the key issue is to, at the aircraft level, to ensure that the RMP system on that aircraft meets the required navigation performance for any given navigation specification where this critical component of the aircraft implementation is needed. We want to ensure that there's lateral and longitudinal navigation performance available during the operation, and that the flight crew knows when that's no longer available. But what we did was some fairly extensive clarifications within Volume 1 and Volume 2 to ensure that this area is discussed in a much more readable fashion so that it's understandable by everyone reading the manual, and it wasn't focused solely on a technical audience like myself and my colleagues from as airworthiness regulators, and that it would make sense to both regulators from the technical side as well as those who are responsible for management of the airspace, and to give every operator a chance to better understand just how this is a critical component of the RMP navigation specifications the manual supports. Next slide, please. I believe we'll transition to Dave Zaituni at this time.
Yeah, thank you, Barry. All right, everybody. I have the final couple of slides here before we get to questions. So I want to talk about magnetic variation, or otherwise known as MAGVAR. So up to including PBN Manual Edition 4, information and the description of MAGVAR was mostly limited to identifying it as a factor in some of the PBN functional capabilities. There wasn't a lot of formal information about MAGVAR in the manual. Over the years, a number of in-service problems were observed, some of them significant. This led to efforts for the industry to consider these problems and offer MAGVAR standards and guidance improvements. That was done primarily through the FAA in the Performance-Based Operations Aviation Rulemaking Committee, and those efforts helped develop into new equipment standards. Those standards primarily exist in documents such as the RTCA and EUROCAE Minimum Aviation System Performance Standards and Minimum Operation Performance Standards for RNAV, RMP and RNAV. Those document numbers are DO-236 and ED-75 for the MASPs, and DO-283 and ED-76 for the MOPs. So there were a lot of improvements in those manuals. Edition 5 of the PBN manual includes a number of updates which integrate the information in those industry standards and equipment standards into the manual. And that guidance is provided in a new attachment. The attachment provides information for states implementing operations where MAGVAR is an element of the procedure or the route, and how it's stored in the onboard flight management systems navigation database. Next slide, please. So the Edition 5 provides some clarifications and additional description and material related to how MAGVAR selection is performed in the avionics equipment, such as the flight management system, and it covers a number of different cases. Those cases, as an example, include things like how MAGVAR is treated at an airport, how it's treated on a PBN instrument procedure, how nav aids are used, station declination, etc. And that applies to how the specific flight management system then applies MAGVARs to what we call leg types. These leg types are how the flight management system puts together procedures, typically in the terminal area, as they're described from procedure designers coming from the States. And the type of leg types that are impacted by MAGVAR are things like the course to fixed leg, or course from a fixed to an altitude, those type of leg, and holding. Those are all actually impacted by MAGVAR, and we've provided additional guidance material in the PBN manual. Even with these updates that we made to the manual, there are still a number of inconsistencies within the industry that are just existing due to the legacy behaviors of certain equipment and how MAGVAR is used, and the fact that MAGVAR changes at certain airports at different rates. And all of those factors contribute to the fact that there will still be some problems seen out there in the real world with respect to MAGVAR, but we hope to have improved a number of them and just explaining how they work in Edition 5. And with that, I think next slide, and I will transition back to Ian to start the question and answer period.
Yes, thank you, Dave, and thanks for all the speakers there for running through that presentation. So we have a number of questions that have come through the chat. I'm going to do my best to sort those and allocate them appropriately. In fact, there's a couple that I'll probably just pick up myself right at the beginning just to get started. One of the questions that was raised during the conversation and also prior to the webinar we had this was about the codes for flight plans for the various different PBN nav specs. And specifically the question was asked about why there is no code for advanced RNP. We're aware that the current edition of the Flight Plan 2012 does not contain suitable PBN codes for everything. This has been a subject of ongoing discussion between the PBN study group and the ATM-RPP, which is the expert group within ICAO that handles this. So we submitted a selection of additional nav spec items. You can see that on the screen now. Thanks, Tomo, for the various different nav specs that are currently in use and that we need to be able to identify. In fact, there's a little bit of a compromise here because there was an agreement that Flight Plan 2012 would not be amended. We're working towards FFICE, the Flight and Flow for Information in a Collaborative Environment, which is the replacement system. And updating the flight plan requirements now would require some fairly hefty investment in flight data processing systems, which really doesn't make sense when we're moving towards this FFICE implementation in the future. So the compromise is that we're publishing standardized codes that will be used in the item 18 nav/, and you can see those on the screen there. So there's RMP2, either Mike 1 or Mike 2, depending on whether it's continental oceanic. There's a specific code for RF leg capability for fixed radius transitions, etc. Advanced RMP is on the list. What we'll see is that the ATM-RPP have started to work on their guidance. and they're updating Doc 9965, the manual on flight and flow information for a collaborative environment, with some of these standardized text. So that the first 5 of those have already been included in that manual. The work on that manual isn't finished yet, and so ATM-RPB are still considering some of the other submissions that we've given them, and advanced RMP is one of those. So it's likely that it will be included at a point. It just isn't in the guidance just yet, but it's coming. So that's what we're planning to do for the additional navigation specifications that weren't included in the original flight plan. Second question, I've had a couple of people asking, actually, now that we have RMPAR DP navigation specification, is there going to be update to the Doc 9905, which is the RMPAR procedure design criteria? The simple answer to that is yes, there is. It's not going to come out right now. There has been coordination between the PBN study group and the Instrument Flight Procedures panel, as Barry mentioned in his presentation. There's some ongoing discussions between those two groups. Now that the nav spec is complete, they can start working. They can't really do their work until the nav spec is finalized, because we need to make sure we understand what the concept is first. So yes, the IFPB are going to be looking at procedure design criteria. There will ultimately be an update to that manual to include that work. I can't say for sure when that's going to come out, but it's certainly in hand as we speak. So I have a question that I'm going to pass over to Jeff here. I think he probably covered it in the presentation, but just to be clear, it was talking about the advanced RMP nav spec and the missed approach segment, and referring to the fact that below RMP 1.0 is RMPAR territory, and therefore there was a question about whether advanced RMP in fact has covers the missed approach segment. Jeff, perhaps you could just quickly summarize. I think you said this in the presentation, but just to reiterate that point.
Yeah, thank you, Ian. Just to reiterate, so advanced RMP, in terms of its normal lateral navigation accuracy, has a missed approach segment of RMP1, but exceptionally, the state may be able to produce a safety case to show that they can use RMP 0.3 in that missed approach phase, but we listed the specific considerations in Chapter 4 that we believe the state should be considering, including the aircraft eligibility and any contingency procedures for extraction from that particular missed approach procedure segment. So yes, it's normally 1, but exceptionally, if the state can show through safety assessment that they can justify 0.3, then they can use 0.3.
Thanks, Jeff. A couple of questions then regarding the RMPAR DP. So Barry, I'm going to be passing these to you. The first one is a question about, so the question is how are we going to reconcile the requirements of FAA 121.189 for a maximum 15-degree bank angle for obstacle accountability with the 20 degrees for RF and the RMPAR DP? And if you can respond to that.
Well, I hope I can respond to it. The way I understand the question is, what we've done is we've provided a navigation specification based on the existing in-service aircraft performance that's available to accomplish an RMPAR departure procedure. We're not trying to compromise any other regulation or guidance material with respect to the manner in which operators may conduct departure procedures today. What we are doing is embracing the full performance of the aircraft, and it's up to each one of the states they should be developing specific implementation guidance for the operators within that state, should the state publish RMPAR departure procedures. As an example, here in the United States, we don't see a big demand for RMPAR departure procedures within our national airspace system. At best, I believe when we've tried to take a look at it, we may have a fewer than 5 or 10 RMPAR DPs at some specific locations sometime in the distant future. But all of those types of issues should be addressed by the state. If there are conflicts with the implementation of RMPAR departure procedures with the state's other PBN implementation guidance and rules. Thank you.
Thanks, Barry. So a couple of questions now on holding, following up from the item that Benoit mentioned in his discussion about the Vol 1 changes. They're sort of related. So the first one being about the RNP holding now is just part of advanced RMP. So does that allow for a smaller hold protected area when it can be used? And a kind of related question on there for PBN holding for everything else, is that effectively saying that it's going to be similar to conventional holding? So Benoit, I don't know if you can respond to those. I might also jump in as well, but do you have anything to add on those ones?
Well, basically, I'm not sure to have more to add to what you just said. It's a good summary of what I explained and what we try to enforce within the new edition of the manual. Or did I miss a question?
Yeah, I think it's right. I mean, so the summary is that RNP holding really only exists within the advanced RNP aspect, yeah. Although in fact there is no, as I understand it, there's no actual design criteria now for that in the
it's going to come, yeah.
Yeah, and for the rest of them, as Benoit mentioned in his presentation, the reality is that most of the systems have this functionality that can be used, but there's no actual specifications for it. So in fact, there's very little clear understanding of what can be done with that system. It's not that you can have repeatable behavior necessarily. So in fact, for the most part, although the reality is that the crew will use the system to fly that hold using the RMP system on board, in fact, the reality is that it has to be treated as a conventional hold because of that lack of standardization of the system and the lack of a defined function. I know we have Corinne Busquet with us as well. I don't know if she wants to say anything else, anything to add on that point, but she was involved in that work as well. But if not, then I'll move on to another question.
Thank you, Ian, and good morning, good day to everyone. No, I think you summarized very well the situation regarding holding. The answer is yes. We cannot expect any benefit in terms of size of the protection area if we use holding based on a waypoint today, because there is no, as said a lot of time now, specific standards regarding the way the FMS is going to perform the holding. So as you said, Ian, nothing can be repeatable, so we cannot create a protection area that could fit with all systems without this standardized function.
Correct. Another question for Barry now, back to the RMPAR capabilities. I think this is a fairly easy question. Is it necessary for RMPAR capability to be listed in the AFM in order to get approval for that nav spec? So Barry, I think that's an easy one for you, I think.
Yeah, so the nav specs as they're written specifically say that you don't require an AFM entry in order to be eligible to conduct RMPAR operations. That is a legacy from when we began the RMPAR program, at least here in the United States, about 20 years ago. So you don't require the AFM entry, but you have to show proof of aircraft eligibility. And there are, as some of you may be familiar, many aspects of unique RMPAR eligibility at the aircraft level that have to be addressed, and addressed from the manufacturer's perspective, not from what someone might think the manufacturer has done in the production of the aircraft itself. So no, you don't need a formal AFM entry in order to support an eventual authorization to conduct RMPAR operation.
All right, it's very clear. Staying with you, if I may, there's been a couple of comments regarding this, the discussion about the one engine inoperative. One or two comments rather than questions talking about certain aircraft types not supporting a secondary flight plan for the AR departure, and then in that case the one engine out situation becomes quite limiting, and also commenting that it seems to be a requirement then that there should be an FMC functioning, and if they don't lose that, then they lose the contingency for the one engine out case. And staying on that kind of related theme, again, a question about whether there's going to be a separate nav spec for RMP AR DP for the one engine out. I think we had that discussion in the group, so maybe you could start with that one and then see if you can address any of the questions about the secondary plan requirements, etc.
Sure. First of all, we did have rigorous debate about whether or not to embrace one engine inoperative as part of the RMPAR DP nav spec. We leaned heavily on the feedback from operators who had experience with proprietary special RMP departure procedures that are even much more demanding than what is embraced by the public RMPAR DP nav spec. From their feedback and the insistence in some cases of some of the state regulators, one engine inoperative performance became part of the navigation specification. While we do have clarity that perhaps the most and best way to address one engine inoperative performance is by ensuring that the aircraft's operating load supports the conduct of the procedure defined path with one engine inoperative. We fully embrace that that's not always possible and practical for many operators and their support of their customers. So historically, for many, many years, I believe we published our guidance material on the airport obstacle analysis more than 30 years ago and have been using it quite successfully since that time. There are options available. Even the option as simple as having a pilot procedure to fly headings to an altitude or multiple headings to multiple altitudes in order to stay clear of obstacles and terrain and get to a minimum safe altitude when they experience a loss of an engine during an RMPAR DP. Now, the one that is correctly identified as being an aircraft-specific capability would be to have a second tailored departure procedure based on one engine inoperative performance and having that procedure as a backup thanks to the unique qualities of the RMP system and the onboard navigation database integration in the aircraft. As I mentioned during the presentation, there are a lot of different aircraft types that support having a second procedure available in the background for use during a departure procedure. That actually came from requests by aircraft owners and operators who wanted to have that available. In some cases, it came explicitly from one US operator who still today does a number of proprietary RMPAR departure procedures that are tailored for their aircraft, and they wanted to have that alternate path immediately available to their flight crews. So that's an option, not a hard requirement, because RMPAR, from an aircraft eligibility perspective, is an option and not a requirement. We just simply try to embrace all of the options that can be available and can satisfy the need to make the FOSA case to conduct an RNPAR-DP operation without making it overly burdensome by creating a new aircraft level requirement or create a requirement where it was just untenable for an operator to get out of an airport once they got in, simply because with one engine and operative at that specific airport, there was no way practical to fly the published procedure. So those options are there specifically as options, including the presence of pilot procedures as a credible option for a specific aircraft and its operator at a given airport with an RNPAR-DP. And I hope that addresses those questions.
Barry, thank you. We had a question regarding the use of SBAS 2D about the LP minima and why this was not mentioned in the SBAS section. I think Benoit is offering to provide a response to that.
Yeah, I think we can clarify quickly. In fact, this picture on the slide was a very schematic slide, and they didn't intended to discuss of all the details. So you should understand 3D as englobing incorporating 2D in this slide. And basically, edition 4 already supported SBAS to LPV and LP, and this was not changed at all in edition 5. So we have, this is why we didn't detail this, of course, in the slide, but it's still there as part of the nominal operation within this RNP approach nav spec. Thank you.
Thank you, Benoit, for that clarification. It's very helpful. Question about magnetic variation. I know Dave Nakamura has been on the call, has been quiet. He was supposed to be running through our MAGVAR work. We had some technical issues. Dave, I hope you're there. Question about if the MAGVAR data can't be updated, what effect does this have on the NavSpec capability?
Well, can you hear me?
Yes, we can. Yes.
Okay. Okay. Well, at least that's working. Good day, everyone. I think the problem is it gets to be very complicated depending on the aircraft systems and architectures you have, because MAGVAR can be spread across capability and data can be spread across multiple systems. So how it manifests itself is kind of determined by how those what state of data there is and how those systems interact when they're used. So there's not really a simple answer to get to that, but if there's more specifics, maybe we can give some ideas to it.
Okay. So I'm conscious of the time. I know we also have some questions that were submitted prior to the webinar that I'm going to hand over to Tomo for. But I'd just like to say I have got a number of other questions that were submitted that we're probably not going to have time to get to. Some of them are quite detailed, talking about the requirements for the RNPAR procedures and design considerations. So those ones we'll probably have to review offline and maybe get some discussion going with the IFPP to respond to those. And as I mentioned before, the intent would be to make those available after the webinar. Also, a number of you have been asking about the presentation itself. Yes, the plan is to make this recording available afterwards. Again, we're still working on exactly how it's going to be done, but we'll publicize the fact that it's going to be done and exactly how once we've finalized that. So I'm going to hand over now to Tomo to pick up one or two final questions that were registered before the start of the webinar. Tomo?
Yep, thank you, Ian. And before going to the registration form, I'd like to pick up the one questions common questions. Very confusing to use term VNAV also for ILS, MLS, and GLS. RNP approach down to the LNAV VNAV minima is also becoming confusing as it only appears to the valve VNAV. This one's relating to the slide of the valve VNAV. Could you explain this one, clarify on the ILS, MLS, GLS topics?
Sure. One of the areas of confusion that exist with RNP approach and RNPAR approach is when do you require approved VNAV to conduct those operations, as well as when can I use VNAV as advisory guidance through advisory VNAV during other operations. So when we took an effort to update attachment A and try to address VNAV in general, we thought it would be clear to express clarity on which approach operations traditionally require approved VNAV in order to conduct that explicit operation, whether or not it was an RMP operation or if it was a conventional instrument approach operation or a unique operation that requires a specialized equipment and airworthiness approval like MLS and GLS. So the only intent in highlighting procedures that require approved VNAV was to make the case that you didn't fly those procedures to the lines of minima depicted on the approach charts for those procedures unless you had the explicit airworthiness approval to use the VNAV guidance that is provided during an ILS from the glide slope, during an MLS from the MLS facility and the MLS installation, and during GLS from a specific GBAS installation in that aircraft, as well as highlight that during an RMP approach, you can use approved VNAV to fly the LNAV VNAV line of minima or the LPV line of minima in the case where your aircraft has an approved installed SBAS sensor that is capable of supporting LPV approach operations. And then if you take the time to read the attachment, you'll see that we tried to clarify when you can use advisory VNAV or those cases where there is no provided line of minima giving operational credit such that the operation permits the use of advisory VNAV to go to an MDA, a minimum descent altitude. And that would be an operation like an RMP approach when the only available line of minima is the LNAV line of minima, or when doing an RMP approach and you're using your SBAS sensor to fly to the LP, Lima Papa minima. That operation, much like the LNAV only operation, is conducted to an MDA. You can use advisory vertical guidance that most systems offer during those operations to conduct a CDFA to the MDA. And we try to embrace the conduct of the use of the MDA as a DA in that case where you're doing CDFA as well. So there's no implication that we're trying to say ILS, MLS, and GLS are somehow now being embraced within the PBN manual, other than to draw the distinction between approved VNAV that you must have in order to conduct a given instrument approach operation and distinguish that from the instrument approach operations where you can use advisory VNAV as an aid to a smooth continuous descent, be it outside the final approach segment or in the final approach segment, in order to try to conduct a CDFA operation and enable a better transition to landing at the end of the instrument approach operation. Thank you.
Thank you, Barry. So now I'd like to move to the questions from a registration form. And Ian, will VPT now be included in this release, or will it be released separately? I think that will be under your area.
Thank you, Tomo. Yeah, so the RMP VPT, or the guidance that we're publishing, which is referring to those procedures that are typically referred to as RNAV visual, that's not part of the PBN manual. it was the discussion of a piece of work that was conducted under the panel with the aim of trying to get some standardization on those procedures which are proliferating. And really the outcome of that work is going to be best practice and recommendation. So it's coming out as guidance rather than any kind of design criteria and requirements. There is a circular that's in the editorial process right now that we're hoping will be published very shortly, but it's entirely separate from the PBN manual. It's not part of the 5th edition. So that's where we are with that one. That was a question that came in through the webinar chat as well. Thank you.
Okay, thank you, Ian. So next questions regarding to the advanced RMP. Are there any regions that have introduced the advanced RMP approval process and the airline have to certify for advanced RMP? If yes, how? So I'd like to ask Jeff and Jeff and Barry, if you can please answer to that question.
Thank you, Tomo. So yes, I mean, advanced RMP has, because that's been around in the PBN manual since 2013, that there have been established approval processes within certainly AirOps and within the FAA advisory circulars, 9105 Alpha being the current one today, and AirOps Part Cat for European air transport. So those processes are there, and it's very much business as usual with any other RMP navigation specification, with the exception that certainly in Europe, RMP-AR is covered under Part SPA, where a specific approval is required. So those processes are there. They just haven't been applied, I don't think. And I think it's important to note that the OEM documentary evidence is there. Certainly the Boeing RMP capability document has had the references in there for some time. So I covered the approval process on slide number 26. And as I said, does the airline have to certify it for advanced RMP? Yes. The term certify is what we would call an operational authorization in this context. So clearly the aircraft has to have an airworthiness approval, but then it is down to the state approval process for just how that ops manual authorization takes place. And it could well be, because of the bundling of the nav specs, it could be well based on pre-existing specifications already authorized, and then an assessment of the functional differences. I don't know if Barry, you want to add to any of that?
Yes, just a couple things, Jeff. One, you don't need an AFM entry in order to be eligible to do advanced RMP. Although I will say that at least here in the United States, our aircraft manufacturers have been doing a good job of updating their aircraft manuals and their operating manuals with clarity on eligibility to conduct advanced RMP operations. And again, the nav spec, like Jeff said during his presentation, it was actually based on trying to get more credit for the very strong RMP performance in existing in-production aircraft when we started the development of the nav spec almost 10 years ago. So you don't need a formal AFM entry to support eligibility for advanced RMP. But like Jeff said, here in the United States, we're working on trying to develop the ops authorization means, as well as to develop a CONOPS for the introduction of day-to-day advanced RMP operations in our national airspace system. Today, we have a handful of very unique applications of advanced RMP during specific approach operations, but we're not publishing those in our AIP yet. They are proprietary procedures. They were actually tailored for specific operators. And once we get our US concept of operations agreed to and published, then we'll most likely transition those into the public domain, and we will publish those in our AIP. So like other states, I think there's a lot of questions about some of the things that Jeff touched on well during the briefing. For example, that idea, if you were going to do a advanced RMP operation in an airport surrounded by mountainous terrain, is that the intent of advanced RMP? My answer would be no. That's the intent of RMPAR approach, to support that isolated mountain airport. Advanced RMP was to try to enable more efficient, high volume operations, in particular at some of the major metroplex airports in the congested areas around major cities in the world. Thank you.
Okay, thank you very much. So I'd like to move to the next question. And for UPR operation, what's Pbn specification for direct segment in North America and the European free route airspace? I'd like to ask Benor to answer the question. Benor, can you hear? So if not,
Oh, sorry, I was mute. Sorry for this. Yeah, so in fact, yeah, this is what we have for direct segment and free route airspace is some discussion which has been added in the manual, as I explained in my part of the presentation. But basically, the concept is that for flying free route airspace and DCTs, there is no specific Pbn requirement. You will use the Pbn capability which is approved for en route specifications. In Europe, this would be typically ANA 5, which would be used, although it is not specifically specified for the DCT or FRA environment.
Okay, thank you. Jeff, do you have any additions?
Yes, thanks, Tom. As Benoit says, I mean, typically the default would be 5 nautical miles, because that in fact is the minimum radar separation standard that's applied in the en route, certainly in Europe, and therefore it is still very much a radar monitored operation in that context. But I think we have to recognize that the majority of FMS, if given a point-to-point navigation, will actually default, if not given anything in the en route flight phase, they will default to ±2. So there is an argument that says that if we were to look at the fleet of aircraft, then maybe we could consider maybe in the future an RMP2 requirement, and then we reduce separation standards perhaps in that flight phase. But that's something that's very much outside of what we published today in edition 5. We did within the study group go to our friends in the SASP and others in terms of trying to get a Pbn assignment for free route and direct routing, but we weren't successful in that respect. So that's where we are today, but there's always a future. Thank you.
Okay, thank you very much. So, and I think it will be a good time to finish the Q&A sessions, and the time is now close to the 11 hours, so already extended schedule. So I'd like to close the session's webinar today too. So I'd like to ask Ian to close the session. Thank you.
Thanks, Tom. Thanks everyone for joining with us today. Thanks for all those questions. I know that there are still a number of questions that we haven't managed to get the time to answer. I have made a record of all of those, and we will do our best to get through those and provide a response. In response to many of the questions, yes, the webinar has been recorded. It will be made available. We're just still finalizing the detail of where that's going to be, but we'll make that clear. It'll be publicized, and then obviously it'll be available to other people to watch. And with that, we'll try and address those additional questions that we didn't have time to get to today and get a response to those interesting subjects that are raised. So it just remains me to thank all of our presenters and panelists today. So Barry Miller, Benoit Roturier, Corinne Bousquet, Dave Nakamura, Dave Zaytouni, Jeff Burton-Shaw, and Tomorozuri from IATA as well. From all of us, thank you very much for your attendance, your questions, and from me, thanks very much for joining us today. And look out for the publication of the webinar video and the answer to all those questions. Thanks very much. Goodbye and good day.